trying to find the critical values for this function. To find the critical values, we need to find the first derivative and find where the first derivative is either 0 or undefined. So I'm going to take the first derivative by using the power rule. 4 times a half is 2. 1 less than 4 is 3. And then 2 times 27 is 54. And that is our first derivative. Because it's a polynomial, I know it is defined everywhere, so I need to figure out for what values of x is this equal to 0. To accomplish that, I am going to factor out a 2x. That leaves us with x squared minus 27. So either this factor is equal to 0, in which case x would equal 0, or this factor is equal to 0, in which case x would either equal the square root of 27, or x would equal the negative square root of 27. And you could simplify that, 3 squared is 3, but I'll leave it like this for now. To determine whether or not these are maximums or minimums, we have 2 options. We can either take the first derivative test, which involves the number line, and we'll decide at these points where the derivative is equal to 0, is it changing from positive to negative, or from negative to positive? Or we could use the second derivative test, which will tell us whether the point is concave up or concave down. So I will use the first derivative test first. I know that the first derivative is equal to 0. At the square root of negative 27, 0, and the square root of positive 27. And what I need to do is decide for each interval, is the derivative positive or negative, because that will tell me whether my function is increasing or decreasing, and that is going to let me know whether or not that point is a maximum, minimum, or neither. So I need to test the interval of the numbers that is less than the square root, negative the square root of 27, which is approximately 5.2. So I'm going to pick a number like negative 10, and when I pick my number, I'm substituting it into the first derivative to tell whether the first derivative is positive or negative. So I will substitute it in down here. If I chose negative 10, 2 times negative 10 is negative 20. Negative 10 squared is 100. 100 minus 27 is 73, which is a positive number. This was a negative number, so I have a negative times positive. So this is negative in that interval. At negative root 27, my derivative is 0. So now I need to test a number in this interval. So I will choose negative 1. 2 times negative 1 is negative 2. Negative 1 squared is 1, minus 27 is negative 26. I have a negative times a negative, which is a positive. Now I'll test this interval. I will use the number 1. 2 times 1 is positive. 1 squared minus 27 is a negative. I have a positive times a negative. So the derivative is negative on that interval. And then last but not least, I'll choose 10. 2 times 10, positive. 10 squared minus 27 is a positive. Positive times positive is a positive. So if I were to sketch very roughly what the graph of this function would look like, not the derivative, but the actual function, I know since the derivative is negative, the function is decreasing. Then it hits 0. Then the function is increasing. Then it hits 0. Then the function is decreasing until again it hits 0. And then the function is increasing. So a very, very rough sketch would look something like this. It tells me that this point right here, this x value here, is a minimum. It tells me that 0 is a maximum. And it tells me that this is also a minimum. So I have classified the 3 critical values by using the first derivative test. Another option would be to take the second derivative test. I'll do the second derivative test in red. The second derivative of this function is, I will take the second derivative from here, 6x squared minus 54. And to classify these critical values using the second derivative test, I just need to know whether those critical values have a positive second derivative or a negative second derivative. That will tell me whether it's concave up or concave down. So I'm going to substitute in negative root 27. And the reason I left this as negative root 27 instead of 3 roots 3 is because it's going to make squaring it easier. Square root of 27 squared, negative square root of 27 squared is 27, times 6 is, oh geez, 120 plus 42, 162, minus 54 will be 108, which is a positive. And then f double prime of 0 gives me negative 54. And then f double prime of the square root of 27. 27 squared times 6 minus 54 is also 108. So here, at this critical value, the second derivative is positive, which means that it is concave up, which confirms that it is a minimum. At this critical value of x equals 0, the second derivative is negative, which means our graph is concave down, which confirms that it's a maximum. And at this derivative, at square root of 27, at this critical value, the second derivative is 108, which is positive, which means that our graph is concave up, confirming that it is a minimum. To find the points of inflection, take the second derivative, and we are going to set it equal to 0. And I can factor that. The only two places that this is equal to 0 is when x equals negative 3 or x equals positive 3. Now, in order to be a point of inflection, not only does it need to have a second derivative that's equal to 0, but it also needs to change sign with those values. So I'm going to make another number line here, except this time my number line is going to be evaluating the second derivative with respect to x. So I will choose a number that's less than negative 3. Let's go with negative 10 again. Negative 10 squared is 100 times 6 is 600. Minus 54 is 546, which is positive. I'll choose 0 here. 0 minus 54 is negative. And then I'll choose positive 10. 100 times 10 squared is 100 times 6 is 600 minus 54. Again, it's 546, which is positive. So it does change sign at both x equals negative 3 and x equals positive 3. It asks for the point of inflection, so I need the ordered pair. To find the y-coordinate that goes with this, I need to substitute it back into the original function, which is 1/2 x to the 4th minus 27x squared. Oh, this is going to be some complicated arithmetic. It's 81 halves minus, oh geez, let's see, 9 times 27 would be 180 plus 56. 180 plus 63, 243. Yeah, that seems good. And then I can make a common denominator here and do my subtraction. So that'll be, let's see, 486. Oh, geez. So this would be negative 405 halves. The arithmetic is going to be exactly the same for positive 3. So these are my 2 points of inflection.